Students, so in this video we are talking about the angle properties or the circle properties. So what are the different properties of angles that are within a circle? So the first angle property that you should know is the angle subtended by an arc at the center is twice the angle subtended at the circumference. That the angle, the angle subtended, the angle subtended by the arc at the center is always twice the angle subtended at the circumference. In other words, if I have a circle, this is my center, I have there an arc. I have there an arc subtending an angle. This is the angle subtended at the center. Then if I extend here and then I extend, this is now the angle subtended at the circumference. And our first property is saying the angle subtended at the circumference, if I call it x, then the angle subtended at the center is twice the angle subtended at the circumference. That is our first property, that the angle subtended by an arc, this one, at the center is twice the angle subtended at the circumference. Yeah, no matter how they have drawn the diagram, it will always hold so bad. So that is a fake circle, this one off. So if no matter how they draw it, the property will still hold. That if I have there that one as the angle subtended at the center, then even though I extend and it does not pass over it, but it moves from the same point of my arc, then it moves in such a form. The angle here, if the angle here is z, then the angle at the center is twice z. That is our first circle property. So our second circle property relates the diameter. What about the angle subtended by the diameter? The angle subtended by the diameter of a circle on the circumference is always 90 degrees. If this is my circle, that is my center, this is the diameter. The angle subtended by the diameter on the circumference is always 90 degrees, no matter how it looks. Even though I don't know how we can put it, even though I stretch from here and I create other lines that are joining the diameter, this angle will always be 90 degrees, meaning the angle subtended by the diameter at the circumference of the circle is always 90 degrees. So what if we look at equal chords? So our third property, let it deal with equal chords. Equal chords. Remember, student, we said if I have a circle, if this is my circle, and I draw a line that does not pass through the center, is what I call a chord. This other portion, the small one, we called it a segment. Since it is small, the minor segment, the other one is the major segment. But here we are dealing with angles. If this is my chord, maybe it is my chord x, y. If it subtends an angle here, if it subtends an angle at the circumference, if I call it angle alpha, if this chord is equal to another chord, this one, maybe now this one is maybe w, z. If this one is maybe p, this one is r. If this chord is equal to this one, equal chords subtend equal angles. So this angle is equal to the angle here because the chords are equal. equal chords, subtend, equal angles. So our fourth our fourth property is the angles that are subtended by an arc, a single arc. If I have a circle, and then I have there an arc, if this is the center, I have there an arc, maybe AB. This guy is AB, this is my center, I can call it center O. So the angles subtended by an arc are always equal. The angles subtended by the same arc, if I have the same arc, if it is producing here an angle, maybe allow me call it gamma, an angle gamma there, as long as it is the same chord, it subtends equal angles. This will also be gamma. Even when I change and I make it pass below, and then it comes this side, it will subtend the same angle gamma. So our first properties, we have said, look at this summary. We have said that the angle subtended at the center is always twice the angle subtended at the circumference. The diameter of a circle subtends an angle of 90 degrees at the circumference. We have said that equal chords subtend equal angles. We are saying the angles subtended by the same arc at the circumference, these angles are equal. So we can look at angles of a cyclic quadrilateral. So if we look at the cyclic, what is a cyclic quadrilateral? It is a quadrilateral within a circle. And then we call it a cyclic quadrilateral because all the four corners of the quadrilateral are going to be touching the circle. In other words, if I have a circle, if I have such a circle, and then I have there a quadrilateral, I have there a quadrilateral, So if I put the angles within the quadrilateral, if maybe this is my angle X, this is my angle Y, this is my angle W, this is my angle Z. The angles within a cyclic quadrilateral hold a very special property that the opposite angles of the opposite angles in a cyclic quadrilateral add up. Opposite angles add up to 180. In other words, these two, this and this, add up to 180, or this and this add up to 180. In other words, they are simply supplementary. Opposite angles of a cyclic quadrilateral add up to 180 degrees. In other words, if I have Z and I add there W, this is equal to 180 degrees, and if I have still X plus Y, this is still equal to 180 degrees. That is a property that we should know. So in this video, student, we've simply talked about the properties of the circle and then the cyclic quadrilateral. In the next video, we are doing some of the sample questions.